All right, 1.1, practice B, number 18. We went from the left side where it's 7 plus, and then in the bracket 2 plus negative 2 is equal to 7 plus 0. So what's the only thing that changed from the left side of the equal sign to the right side? This became, so the part here became 0. So what did we do? What does that mean? If it became 0, additive inverse. Okay, what's additive inverse say? That if I add two opposites of each other, it's going to be 0. All right, 1.2, Foundations 1.2, Algebraic Expressions and Models. Basically 2 goals. Evaluate an algebraic expression, and then simplify algebraic expression by combining like terms. Okay, again, this is all stuff that you did in Algebra 1, so it should just be a nice, easy review to go from there. So, a little bit of vocab. A numerical expression consists of numbers, operations, and grouping symbols. So, a couple different examples. You have one that's pretty extravagant with 4 plus 3 squared minus the parenthesis of negative 2 plus 7. Okay, where there's a lot of things going on. You have grouping symbols, you have exponents, and then you have just regular operations with adding and subtracting. And then in your second example, where you just have it just as simple as 2 to the 5th power. Okay, both of these are considered numerical expressions. It doesn't matter how big or how small, it's still a numerical expression. Okay, numerical meaning that it deals all with numbers. So whenever we evaluate a power, okay, was whenever we raise a base to a higher power using an exponent. What's the only thing different between the first example and the second example? What's the only difference? Where the negative is, right? One of them, the negative sign is on the inside, or inside the parenthesis, whereas the other one, it is not. So whenever we do this, if you have a negative outside a parenthesis, it's not going to get taken to the 3rd power like the second one is. Okay, so the first example is really just like negative, and then I'm going to have 3 times 3 times 3. What's 3 times 3 times 3? 27. So my answer is negative 27. Whereas in the second one, even though we're going to get the same answer in this case, it's still going to be different because it's going to be negative 3 times negative 3 times negative 3. So negative 3 times negative 3 times negative 3 is still going to be negative 27. The biggest change or the biggest time that you're going to have a discrepancy is whenever it's going to be an even power. Okay? Or if there was another negative inside of the parenthesis, okay, we don't distribute that negative inside. We do the exponent first, and then we worry about the negative. Then you have different terms. Okay, terms are just part of an expression. Okay, you have monomials, which means that you have a single term. Constant terms, those are just what you would consider constants, or just like numbers, 5, 2/3, negative 17. And then a variable is going to basically, is going to combine the two. Okay? It's going to combine your letters and your numbers. Okay? A constant will always be just a numerical value, whereas your variable will have some sort of letter to it. Okay? An X, a Y, a Z, a Q, whatever. It may be taken to a power. it may just be that number. Or just that letter, like x. What number is really in front of x? Like what would the coefficient be of x? 1, right? So the coefficient is the number that's in front of a variable. So like on that example where it says the variable term, in this case 1 would be your coefficient. Here 5 would be your coefficient. -2 would be your coefficient. It's whatever the number is that's in front of the variable. Okay? Even if you don't have a number that you can see, there is still one there. It's the 1. The only thing different from a numerical expression and an algebraic expression, they're still going to have grouping, they're still going to have operations, it's still going to consist numbers, but the key here is that it's going to have some sort of variable. The difference between a numeric expression and an algebraic expression is that the algebraic expression is going to have some sort of letter or variable with it. Okay? X squared plus 3y minus the quantity of z plus 7. Okay? Or 2x to the 5th plus 7x plus 3. Algebraic is going to have numbers and letters or variables. Numeric is just going to be strictly numbers. So then, last one, it says two expressions are equivalent if they have the same value for all values of the variables. So 5x plus 4x and 9x are equivalent because what's 5 plus 4? 9, right? Good job. Good math. Even on a Friday we can do that. It's good. You haven't checked out completely yet. That's what I like to see. Then, you remember order of operations. Okay? You were probably taught PEMDAS. Please excuse my dear Aunt Sally. Now, whenever we do PEMDAS, remember the P stands for parentheses. Once I do everything inside of the parentheses, so inside of the parentheses or the grouping symbols, whatever you want to call it, I'm still going to go about my business as far as doing exponents first inside the parentheses, multiplication or division from left to right, and then adding and subtracting the same way, from left to right. Okay? You all are at the point where you shouldn't make this mistake of doing adding first and then subtracting. You just go in order, just like how you read, from left to right. If you have a AA2 or any sort of graphing calculator, it will do PEMDAS correctly if you enter it into the calculator correctly. Okay? If you enter it into the calculator correctly. If you forget a grouping symbol or a parenthesis, it's going to read it. That calculator is only as smart as the finger that pushes the buttons. Okay? Or as the person that's pushing the buttons. If you don't, it can only do what you tell it to do. So if you miss an exponent or if you miss a grouping symbol, then it's going to read it as is. Okay? Depending on which one you have, if you get like an 83, like if you take something to a power and it may be negative, you're going to have to put parentheses around that. Okay? We'll get to that. That will be second semester stuff, but just know that that's kind of important. The newer ones will actually, whenever you take things to a power, it will like physically put it up as a power and make it smaller. So it just depends on what you have and what you're using. So it says evaluate the expression using PEMDAS. What do we have on the first one?
You want to go through the steps?
Huh? What did you get the answer?
34.
34. So I've got a 34. I don't have my marker. I've got some saying yes. Anybody saying no? Do I have a discrepancy or... Yep. Negative 16. So I've got 34, I have negative 16. Anything else? Okay. So that's on the first one. What about the second one? I heard 312. 312. Anybody want to venture out and say that they got it right and it's not 312? Okay. I have two of those answers. I don't have one of them. Okay. Here's where you messed up. You made it negative 5 times negative 5. Okay? Right? Okay? There's no grouping around that 5. Okay? And that's all right. That's going to happen. Okay? I'm 36 years old and I make math mistakes all the time. It's really okay. There are greater tragedies in the world than missing a math problem. Okay? So I originally just had negative 5 there until I saw that it was squared and I was already done. So the first one I did inside the parenthesis, and so I had negative 4 plus 7, I had the 3. I went ahead and did the 5 squared. Since it's not in parentheses, then the squared only belongs to that 5. Okay? So that squared only belongs to the 5, so it's going to be minus 25 at the end. 2 times 3 is 6, and then once I get it to all pluses and minuses, I'm just going to go straight across. 3 plus 6 is 9. 9 minus 25 gave me the negative 16. Same way over here on the right side. 1, I changed the 2 negatives to a positive. Did everything in here first. So 1 plus 3 is 4. 4 to the third. 4 times 4 is 16. 16 times 4 is 64. Didn't have a calculator, so I had to kind of do it the long way and go 64 times 5 and get 320. And then now we have a negative 8 plus 320 and get 312. Then whenever we combine like terms, okay, we simplifying and evaluating expressions. Basically, you want to combine like terms. They have to have the same variable part. Okay, so adding and subtracting is combining. Okay, whenever you combine, you can still subtract and combine because you're just adding a negative number is all you're really doing. So the constants and the variables. So if I only have a variable that is the same, do I have another n squared somewhere? Yep. Here? Do I have any more? No. Again, like we talked about earlier, even though there's not a number there, what number is actually here? 1. So what's 6 plus 1? 7. So I have 7n squared. I'm just going to go down the line, okay, until I don't have anything like it. I have a 5n. Do I have any other n's, just a straight n, not n squared, not n to the third, not n to the 17th? I have 5n, and then I have negative 3n. So what's 5 minus 3? 2n. So I have a plus 2n. Keep working my way down. Negative 4. Do I have another constant? The 8, right? So, negative 4 plus 8. Positive 4. And then the only thing left is a negative 3n squared. So with the negative, whoop, wrong thing. Now, I'm not finished here. Okay? Oh, it is cubed, not squared. Thank you. There you go. Now, I'm not finished here. Okay? You're going to go ahead and start getting into the habit, and you're going to get into a good habit now that you go with the highest power first and you work your way down. Okay? You write it in what's called standard form. So what's the highest power? The cubed, right? So whenever I rewrite this, I'm going to go negative 3n to the third plus 7n squared plus 2n plus 4. And I know you're not going to do this, but just because, don't just combine everything. Okay? Do not let that happen. Now, if you want, it's completely up to you, and I would probably do it this way. I would probably look for the highest power and then go from there and then work my way down. That way, I wouldn't have to do this step here and then change it. I would just go ahead and find the highest power. But that's completely up to you as far as how you want to do it and how you want to roll. What are we going to do here? Is there anything I can combine inside the parenthesis? Nope. So what am I going to have to do? Distribute, right? So whenever I distribute, I'm just going to take that 4 times the x and times the negative 3. So I have 4x minus 12. Negative 9 do the same thing. So I'm going to have negative 72 plus 9x. Once I distributed, combine like terms, 13x minus 84. How are we going to evaluate? What does evaluate really mean? If it says to evaluate, what does that mean to do? What am I going to do with that 3? Plug it in, plug and chug. So really all I'm going to do, anytime it says to evaluate, they give you a value, just plug it straight in. So 4, 3 squared plus 3 times 3 minus 5. $40. Whew. Okay. Negative 9, that's going to be 18. Then we get 4, negative 21. Then I didn't worry about the parentheses of the minus. 9 plus 4 minus 5, so we got 8. Turn that into a negative. 1 minus 8, negative 7. Yes.
If we do shortcut kind of like that, would you kind of wrong?
No.
Okay.
No. If you, as long as, and this is a good question, of as far as like on tests, as far as how much work you've got to show, you obviously need to show something, so then if it does go wrong, then I can give you something. Okay? Like if you would just go, hey, negative 7, and that's all you had, or say you had that negative 15 or whatever I said, okay, and that's all you had, that wouldn't go well. Okay, because that just shows me you're just throwing something out there and I don't know kind of the thought process. Now, if you shortcut it here and say maybe you just went, you went 29 because you have a 2 and a 9, you went 29 and you just started going. Okay, then it's real simple. It will just easily, it's just a small part. You made one silly mistake and we'll go on from there. Okay, I'm not going to hammer you for making a silly mistake. Okay. Now, if it's a bonehead mistake, that's different. Like if I've preached something for like 2 or 3 weeks straight, especially whenever we get into graphing some of these functions, then yeah, I'm gonna come in. I'm just gonna take my foot and I'm just gonna kick you in the rear. Okay, not really, but really. Okay. So here it says you open. Is this the right one or is it the next one? That was the right one. You open a savings account, $300 with your new job. You figure you can deposit $75 per month. Assume that you will not withdraw any money or make any additional deposits. You write an algebraic expression. I don't care what number or what letter you use. Okay, and then after 3 years, how much money will the account hold? And then how many months will it take for you to have $1,000 in your account? You do it. Which one? I'm assuming on A you did okay. 300 plus 75D, right? As far as your expression, you may have went 75D plus the 300. I've got two answers down here on B. One of them's right, one of them's not. Which one's right? What's wrong? How did I get the 525 though? Yeah. 3 months, right? What do I have to make sure I do? 3 years. Okay? Again, it's all about making sure you read that question, you go from there. Okay? 3 years, 36 months, 3 months, 3 months. Okay? There is a difference. Right? Your assignment's on Canvas. Make sure you pay attention. Again, like I said, make sure you read what it says as far as the assignment. You're only doing the odds there. Okay? And then here you're doing all of them. Okay? And it says, it breaks it down like what C and what B is.